Labdien! Mans vārds ir Andrejs Briedis, un es šodien būšu jūsu pavadonis konferencē klimatā.
Good morning, ladies and gentlemen. I will be moderating the conference Climate-Friendly Agricultural Methods today. And of course, climate change is a very topical issue today, both in Latvia and worldwide. And farmers must provide and contribute their share to mitigate climate change and adapt to climate change. In Latvia, approximately 20% of all the GHG emissions are related and associated with agriculture, and of course the mitigation and reduction is not as easy as it seems. In our conference, Climate-Friendly Agricultural Methods, for our online conference, we tested 3 agricultural methods which could contribute to mitigating climate change and help us adapt to climate change. These methods were comparatively rare, used in Latvia and tested and validated before. This is controlled no-till, controlled drainage and utilization of modern IoT sensors in agriculture. In this project, Latvian Nature Fund, the Environmental Solution Institution, as well as KKC, and Scientific and Community Center of the Czech Republic. The project was financed by LIFE program of European Commission and co-financed by the State Regional Development Agency. And specific activities of project were co-financed also by the Social Integration Fund, and some speakers today will be presenting in English, and they will be simultaneously interpreted into Latvian. We are broadcasted currently and are on air on YouTube channels and Facebook platform today and currently. Interpretation into English is provided on a Zoom platform, where you can choose or change the language for interpretation under the icon or pictogram globe. You can ask questions. Please pay attention to the screen. You can use chat or also question and answer session in Facebook and also in YouTube. And as far as we can, we will try to answer all the questions and ask all the questions to each speaker after his or her presentation. And we have reached the first speaker, Jānis Kažotnieks from Latvian Rural Advisory and Consulting Center, who will tell about no-till technology for emission reduction. Good morning, thank you, our dear moderator Jānis. My name is Jānis Kažotnieks. I'm the head of engineering and technical department of Latvian Advisory and Training Center. I participated also in drafting the application for Craft Life project. When we drafted it, seemed quite unpromising, but our hope increased because we really saw and considered it as a turning point in agriculture. And in 1999, I witnessed that in the United States many years ago, and that has really stayed in me. And in 2016, when we were preparing that project, I considered it to be an opportunity to really implement and realize that in Latvia as well, although at that moment there was quite a lack and deficit of knowledgeable experts in Latvia, and we had an opportunity to get introduced with one Finnish colleague, but accidentally, but I do not believe in accidental acquaintances and events and developments in our lives. And it turned out that he was a no-till pioneer in his specialty and in his field of expertise. So we became friends, and I am sorry, there are some disturbances and noises in the broadcast. And starting from 2018, there were more people who had experienced already in no-till technology. If we are speaking about no-till in general, we can remember and imagine our national folklore and folk songs as a person was tilling up to the hill, and there is some smart guy coming and telling that there is no need and no use of tilling. Then we will not be speaking about whether tillage is necessary or not, but as having a picture like that, perhaps in specific conditions and circumstances it is needed, and the most important is to understand what we should do and why we are doing that, and how that coincides in our ecosystem or in our system of actions and lines of action. Perhaps there are some wild boars who are also making some impact on soil or not.
Tas ir viss vajadzīgs.
And the question, of course, remains whether it is really needed. And what happens with emission when soil is processed and cultivated. And if we see a picture like that, the question is for how long we can continue like that, and how expensive that will be in terms of time and effort. But to understand what emission actually is and what is important for that, we should understand what happens in nature. And taking a look in a picture on the slide, that there are trees growing, there is grass, there is a pond, there are some also plants, aquatic plants, etc. And we consider and perceive it as obvious and that it is logic, and there should be no idea what happens because everything and all the processes will happen by themselves in nature. But we can ask ourselves whether it is truly so, and that a human is not damaging something to this natural ecosystem. But in the picture we can also see a road already established, and there are some houses, of course, that the nature also would look and scenery would look very nice also without those haystacks and without houses, without road and without electricity posts. And nature perhaps would be really happy that nobody is disturbing it. But actually everything is coming and going, and extremes are occurring more and more often. And this year, I think we had 4 winter seasons, and as much snowed in 2 days as in 4 months. Then, by means of rain, that all the mass of snow melts in one night, and something really has changed. And therefore, to characterize it, we can take a look back what happened at the end of summer in 2017, which actually reminds some tropic rainfall damages caused in some South America country, but it was actually in Latvia, summer 2019, when we had totally different process, not flooding, but actually really a drought, which was very hot, and that was the first year. Then we started sowing in autumn, and in the farm we were sowing. It was a totally clayish soil, and I had come to the place, and a sowing machine came, and I thought that we couldn't sow in such a soil, but actually everything germinated, and although it was totally disastrous look at the first sight, but we could really witness that technology really worked, because if such a really hard clay would be tried to be cultivated in any other way, and even that it would really hold and keep the seeds, and really seeds could germinate, a week before, the first field really germinated when no-till technology was applied, and it was wet enough for a seed to have contact with the soil, with the minerals and all the nutrients, so that it could really propagate. And our season, winter season 2019-2020. With the average temperature deviation from the standards or from the average in Celsius degrees, it was totally warm and it was above zero. It was the first year I witnessed myself in my life of that there was no snow at all. So winter 2022, this is not spring, this is January, this is winter time. In a place where water was never before. And this winter, we had also similar pictures from Jēkabpils region. So we had last summer 2023, with apocalyptic pictures like that from extreme conditions, and we do not know. We couldn't imagine that it is somewhere in Latvia or somewhere in United States on really total plains, lightnings like that, and almost cosmic finals with huge precipitation, which was catastrophic for one region in a lane in Latvia. But this is reality we have to count on already. And the question is what we could do and what we could remediate. But unfortunately, we are striving, humankind is striving for more, for better, for bigger, etc. And we are using more fertilizer doses, more capacity and power for machinery. And the biggest problem of machine producers and manufacturers is that the largest width of machines could be produced. But the question is how these machines could really be transported or could be moving on roads, because the road width is not changed. And the question remains in favor of what we are doing as we are, and what food and feed world needs, and what nutrients in Africa, for instance. And the question is whether we should really learn, or we should provide feed and food to people in other continents, or finally we should learn and teach them to cultivate their land or adapt to the conditions they are living in and strive for the best. So it's and of course, there are total and very huge differences in different continents. Somewhere is summer always, and it's very hot, and they do not have winter time, and they haven't had any chance or any need to worry about wood for fuel to keep their houses warm. And they should never forget about nature, how that impacts nature. So the question is whether we wish like that I have nothing against rapeseed. The question is whether rapeseed should take over human houses. But if we are growing one and the same species or one variety in the same field for many years, do we need herbicides by systemic feeding and nutrition of those, for instance, weeds and other species we are not wishing to have in our rapeseed field? In the world, there have been more crazy times and hard times. So, in a historic perspective, we would be quite okay. So, historic global temperatures based on the scientific calculation or simulation for the last 500 million years. And on horizontal axis, we have million years. as well as average global temperature on the vertical axis in Fahrenheit, ice caps gone. So we have blue line curves and red curves. We are in the middle of this red curve with average ice age, because somewhere is ice and snow in the world on our globe, and the world has survived that. Average temperature was 40 degrees and average water temperature was 30 degrees. And why should we worry? Because it becomes warmer and we are strong, we can survive that as well. Of course, if we compare Fahrenheit with Celsius, so 60 degrees Fahrenheit is only 15 degrees Celsius, and there is no problem because it's temperature quite okay. But of course, where the blue curve ends and a red curve begins, we can, so it has already been on the globe that all the snow and ice had melted. And yes, there will be also different ice formations and also glaciers, but reality will be and is, if we do not change anything, and this is really good example how we should respond to the term Green Deal, because there are very different opinions in the world, and majority of people say that it is actually some imagined problem. But if we take a look at a mathematical model for the situation 50 years ago, which is one generation time for humankind, and it seems that figures and in 50 years actually it is a very short period of time for our globe, and these black dots and black regions already will be not fit and suitable for human living in 50 years time. Indian Ocean and north part of the ocean, the coast of Indian Ocean, so people will need to migrate somewhere to north, somewhere to west or east, because the south will not be fit for humans. And the question is whether we do not have any problems with climate change and with nature, with environment, and we should do something. Therefore, our project is one of the examples to show that agriculture can be different as well and can be climate friendly, coming down to the basics, and that is soil. And the main resource, it is soil. If a human has a strong immune system, he or she has a strong health. And if something is wrong with immunity, so it means that there are some problems with everything else. And we can also make an analogy to soil. What makes a soil healthy? These are chemical processes, these are biological processes, and that it devotes approximately 90% to the health of soil. The more organisms are in the soil, the healthier soil is, and every process in soil can be contributed and devoted and depicted with some chemical formula and chemical processes taking place. And of course, there are physical processes, which is composition of soil, structure. All these three domains are intertwined, and if some changes take place in one of those processes, of course, it impacts also and affects other processes as well. Content of organic matters actually is nutrient for everything living in the soil. Of course, soil is alive, and if such live organisms are not present in the soil, so this is just growing media and not fit for. So we know what is NPK, but do we know what or C, which is carbon? And it is also one of the fundamentals for and characteristic features of healthy soil. This is feed for all the living organisms in the soil. And how we can make soil healthier? We can improve health of soil by reducing the intensity of processing and cultivation, because soil and living organisms in the soil do not like being disturbed, including also rainworms and also mushrooms and fungi. So we think that mushrooms are growing only in the wood and fungi. I was convinced myself of that. If I noticed small mushrooms growing on the field, I considered it to be very bad. But actually, it was a feature of a healthy soil.
Saimniekošanas sistēma jau ilgus gadus.
Regardless of the traditional processing system, for many years it was so when we harvested the yield in autumn, we were plowing and leaving all this for winter, but it is actually not good for soil health since there are very many different risks, also for leakage of nutrients and also evaporating, and it is the worst thing is that we do not use the potential what the growing plants give to us, also for instance attracting carbon or and also this diversity is the buzz name which we should use and which we should work with, and there are no monocultures in the nature. All plants and everything is growing interrelated, and so this in agriculture we have to bear in mind, and we have to use the cooperation between different cultures, plants, and it will be a better future for all soils. And if we have living roots in the soil, then it means that in the roots there is living substances and it is life. And since as long as something is growing in these roots and around the roots, the soil is healthy. And when we look at this picture, this is the food chain of soils. This is a special topic to speak about. So on the left side, you see everything what is that can be consumed and sun light, and on the light side, everything what is consuming all this in a longer term. This is going on very slowly, and therefore it is very sad to see intensive processing of soil, especially in spring when the soil is disturbed and the soil is just blown away by winds, and then it's and the less we touch the soil, the better it is, and the nutrients are left in the soil, and all for those bacteria and fungi which are in the soil, so they have everything for them in the soil. And the big surprise or the miracle of the nature, photosynthesis. So we know that it is sunlight and oxygen and also carbon dioxide. So all this is being used for this process, and also water. And this is very topical for every plant to grow in different processes, is producing nutrients. And then your question in this picture, is everything okay here? And if I have posed this question, then most of probably something is missing here. And here, these are nutrients which are in the soil, which are produced by different organisms in the organic matter, and also sugar, which is produced by the plant. And it is actually very interesting that sugar is produced, and sugar C is actually carbon here, different compounds of carbon. I write this as a sugar. So the plant produces sugar to survive itself, and also to pump into the soil through the roots, and the zone around the roots is that zone where we have the most of all these living substances and matters, and actually plant is taking care of the soil and soil gives all this back. So they have perfect communication among themselves. And we shouldn't leave the soil bare or black. And one thing how to find this is the intercrops. This actually works perfectly. And here is one picture from these projects, and also the picture from Estonia when they when they use intercrops, different Facilia and different others, and we see the color of soil and how deep these small roots are, and this means that really soil is healthy and density is equal in the whole depths. And here we see this picture even closer, and we see the color. And when speaking about this project, I have myself had the task to take samples of soil and in all the 5 places, and we see how soil has changed its color and structure through these 5 years. Also, the turnover of water has changed, and also the smell is different, and roots are deeper and deeper, and it is live. In the first year, it was we use a spade, and you could not put it through, but now you can dig the soil, and it's healthy. And if we speak about loosening, here is one example. Not about heavy loosening, but also small roots loosen the soil, and when they do not grow anymore. Even see we have channels, and also then water can circulate and air can circulate, and also uh, in intense rain situations, field is not flooding because it is drained deeper in deeper layers, and when it is dry, then this moisture comes back through capillars to the surface of the soil. And this is very, very important when we have these extreme climate conditions which we face now, the long-term droughts and the long-term rains, and this like it is like amortization. Then crop rotation is very important. No use of changing technology if we do not have crop rotation, and we have to understand that by using crop rotation, we produce different sugars, and these different sugars are needed for those matters in the soil, and each living matter needs a different sugar, and the more diverse sugar is, the better these matters feel. And if he says there is, I do not have money, I do not have time for rotating these crops, and they do not make me profit and not a big yield, then we have to remember then for what is it done? Do we try to get out the maximum out of our fields and soil, but are we calculating and trying to find the best for our soil, and understand that the success or key success is the best ratio between the input and output. And yes, oxygen and carbon is in the air, and we have to sequestrate it, and we have different plants which can catch this all and bring back into the soil. And again, we come back to the nature, that nature is diverse, and if we look at this meadow, we really see that it is very, very diverse, and we have come to the technologies. There are 3 possibilities. One is traditional, so it is so disc cultivating and compaction and possible compaction also several times when you have had different plowing, or minimum or min-till. It is first so processing of the soil and drill. And if it is direct drilling, then only one tractor with which we can drill our crops, and that's it. And so all arguments that direct drill is very expensive, so we can remember that if we need traditional processing, then we need 5 different devices or equipment, and here is only one seed drill. And one project and study about carbon in 19 days. So you will see on the scale the differences. It is. We do not have so many studies in Latvia, and I have had studies from America where we have similar weather conditions close to Canada, and the emissions when we have traditional processing of lands, and it is 3.2 tons a hectare. When it is mint hills, then it is 3 times less, and the flame is like this. When it is direct drilling, then it is just a little bit more than half a ton. And why? Because in a direct drill, we just open the soil and close it when this seed is inside. When it is traditional processing, then it is blowing and loosening, and every this device which is working also will produce CO2, and it will burn all this, and it will be in the air. So here is a link to that study and the system what we do by plowing. So our benefits from the LifeCraft project, so basal breathing of soil has increased through these 5 years. The more intense the breathing is, the better for soil, and the more healthy soil is, and more matters there. The intensity is increasing, and it proves that the soil is more and more alive. Also, organic matter is more, so content of organic matter is seen on this picture in different farms, and this is increasing constantly in these farms, and because we are not burning this. And with density of soil, also here we have uh, showed that density should increase as if we are not plowing. It has increased during the first year, but starting from the second year, we saw that the density was reducing, and we also have a forecast that it will return to the level before implementing of the project. And this we can see here in this picture. And about crop rotation, picture and so for the project, precondition was that the farmer, we do not change the way farmer thinks, and we saw that at the beginning of the project, farmers used winter wheat and rapeseed, but with years they also used beans and peas, and people have understood that they need that crop rotation, and that they have understood, not somebody has told them to do like that. The question is it good or bad? There are minuses, and the first is that changes are not immediate. The question is it really a minus? You cannot expect your soil to become alive again through 1 year. All changes should be applied, possibly smaller income, smaller yield. But in our farms, test farms, we didn't see that the yields would be smaller. Actually, we had to look at climatic conditions, but this was not related to the way of processing. There are also pluses, saved resources. So we see that the crop rotation and also intercrops, so we can reduce usage of nitrogen by 30%. We saw that environmental condition improved, also health of soil improved, organics, also moisture and air turnover has or circulation has improved, smaller emissions and more optimal costs. And we see that from 1 hectare, fuel has been saved 50 liters. And when drilling, then we see that this is half a price, and from 1 hectare, cost saving was approximately 120 euros. And it would be natural if you had such emotions after seeing this, and just would like to say thanks to the project for possibility to do this, and also thanks to Latvian Nature Foundation that they participate in, and also Timo, the person from Finland, whom I referred to before. Thanks to Andris from Farm Ozoli in Latvia, Rihards Kadīros, who initiated all this process in Latvia. Thanks for listening. Thanks for those who participated. Thanks for those who we didn't mention here. And this is who I am, and if you would like to contact me, you are welcome. I am always happy to help, assist, and provide assistance. And before we give floor to the next speaker, we can here be very calm, and we have spring outside, and birds singing, and everything is green. But there is one country which is fighting also for us, and we should remember these people. We have to help them as much we can because they are fighting actually for us as well. So thank you, Jānis. And we also have possibility to ask some questions here. And there is a rather classic question. And when farmer asks, how is it actually in real life? So we were taught that we had to plow, and it is a way how to get air into the soil. And now you're telling that you shouldn't use plow. So what is correct way of doing things? In any way, this is what I was telling. This is actually possibility to try yourself. For me, it is not needed. I have understood this already, that this really works, and this could be characterized very well. I was really a fan from 1997 for plowing. I even wrote a book about plowing, and I was also traveling around Latvia. I was teaching people to plow, and now I'm teaching not to plow. I also have the. So if you were listening to me, I also told what it is and what it is not. So what we achieve by plowing and what we achieve by a different way of processing. Everything changes in life, and if we see trends, only then we can come to logical and long-term sustainable management. So otherwise we are just going in direct line and not changing anything. Thank you very much. And we could say that you recommend to see the presentation once again. Yes, but it is not so bad situation actually. As we see, the very much information is available. All this, and I always tell people you have to say to yourself, yes, I'm ready for changes. I want to change, and then the door is open, and then you can go and consult and see. And the next speaker, Ivars, is one of those who is ready to share information, and there is really vast possibility of getting information, and we have to do this. And in general, how would you characterize the attitude of farmers towards these climate more friendly processes? And there are farmers who have changed, who have tried this and have changed their technologies. Okay, but you can go around in the countryside and see what's going on, and we see that more and more there are such fields where they do not plow and where they use no-till technology, and less we have farmers who are plowing. I think that Ivars will tell about no-till and how he started and how he is happy about this, that he is not striving anymore. Actually, this is a task to yourself and question to yourself, but I encourage you not to struggle. Live, be happy, and do everything for yourself to be healthy. Thank you very much. And we will give floor to the next speaker, who will be Aivars Cimermanis from Farma Aņi, and he is going to tell us about experience of no-till technology on the farm. He is open to different new methods, different new information, and so we will hear about no-till in his farm. Aivar, look, please.
Good morning, ladies and gentlemen. I would like to share my experience in farm Angi. Our farm was reestablished in 1996. It is a family farm. Currently, these are 320 hectares. The farm is growing wheat, 160 hectares, oil of rapeseed, and 80 hectares, legumes as peas and chickpeas, 80 hectares, and our crop rotation is winter wheat, oil rape, winter wheat, legumes. Starting from 2019, we are participating in the LiveCraft project for us to start testing no-till and direct drill, as Jānis was considered to be a very credible source of information and experience. Therefore, in 2020, we also bought also strip till sewing machine, summed DTS 4-meter wide. We are working in Zemgale plain. 60% of soil is very heavy clay, and mainly it is with a very high potassium level, low phosphorus provision and supply. So when before the project we had classical scheme, we were following a very classic Senegalese crop rotation, wheat, oil, rape, legumes from 5 to 10% of our area as third crop. 100% drilling was used after wheat. Very intensive phosphorus fertilization was used in spring, 180 to 200 kilos per hectare of net substance. We had also problems of wet clay being drilled. It dried very fast, and it was really hard to cultivate and process the soil. Therefore, 2 to 3 cultivation cycles were needed, and it was really hard to establish and create a very high quality seed bed, and also germination was very poor. And also we witnessed and experienced that if clay was cultivated dry and no rain or precipitation followed, it was very hard. And before the project, our soil looked like that after drill, after 3 cultivation cycles already. And the question arose, what to do next. Therefore, we had this never-ending fight with hard clay, and thanks to drought in 2018 and 19, as well as 2019-2020, was followed by an offer from Mr. Jānis to participate in the project. My dad and myself agreed to the project, and it also helped that that year Jānis took us to Richards Kadīros to farm cells who had experiencing the no-till technologies for 5 years already, and in conversation with him and why Richards changed his technologies to direct drill was those problems I was prevented from good results, and I understood that we had to buy that sewing machine for direct drill. And from childhood I wished to work in climate or nature friendly ways, and for us to attract CO2 more than we emit, and also phosphorus gas and oil are sources for phosphorus fertilizing substances. And as Yanis mentioned, I like Latvia as it is. I am happy about the world and globe we have yet, and my belief is that everyone should contribute to sustainability and preservation of our world. During the first year of the project, that field had aggregates were less, and we were happy that drill and cultivation after wheat was very good, and we saw wheat on September 3rd and September the 4th. September 27, I would remind you that summer 2019 was as dry that from the May to August, the total precipitation was only 8 millimeters. And I do not know whether you can see, but were some very small roots of wheat seed which had dried away already. And sewing a machine, we had sown winter wheat after oil rape. On September 12, we were very suspicious and doubtful about that field to germinate, but on September 27, we already stated and observed that wheat already germinated, although there was no rain or other precipitation. Our story continued. October 11, no precipitation in general, and we saw that clay field was waiting for its opportunity, while on the right picture we can see the first direct drill. So drilling and oil rape was very poor quality and were some weed, but in the beginning we have to get used. If before a human and a farmer had used to a very clean field after summer crop and it was cultivated, and we really grew liking the fact that no-till really field looked very alive, and that life comes out of lively and living soil. Clay was wet enough. On the left picture, on the right, it was our experiment field where all rape was very poor and a lot of weed were present, but germination was very good in springtime. Thanks to fertility of soil on the left, already grew very well, but no-till field on the right really succeeded over and won over the left one. And our main benefits was that we did not lose wetness due to cultivation. Our dependency on precipitation in drier years and dry seasons diminished. We solved the question or the challenge of field germination and also seed bed preparation. We have reduced quite significantly the amount of fuel needed for cultivation and for sowing, which was 40 to 50 liters for drilling and for tillage, and now it is 9 to 15 liters per hectare. And also the sowing process is cheaper because we have saved approximately 80 to 100 euros per hectare, and only one driving for sowing along the field is needed without tillage, and a lower contribution or a labor intensity exists because drivers and farmers do not have to work during nighttime. Also, I am happy that we are working, all our family members are working in the field, but I have heard from other farmers that there is a deficit and lack of labor in the countryside. And it was hard to get used to that we were cultivating from early morning to late at night in turns and in shifts, and did our best for succeeding in a direct drilling that is not needed, especially if this is filled after wheat, it stays wet, and we cannot, if we cannot continue, and we have not to continue sowing during late night, we can come back to our family, spend time with our family members, with our children, and we return to the field in the morning when the wetness is already dried. Excessive wetness is dried away already. We have 4-meter wide sewing machine, and I haven't encountered any problems for our machinery to participate and to provide that no-till technology and direct drilling. And also direct drilling for 3 years, for the first 3 years, usually is a reduction in yield, but we haven't experienced that in our field. We have experienced increase in yield of winter wheat. For beans, the most significant factor is a dry period during flowering, blossoming, and beans were okay, but the dry period and hotness was so high that flowers dried away and less beans were propagated. We had also for legumes 50% of damage due to that extreme precipitation, and drought was our enemy last year as well. But despite of the dry period in 2019-2018 were quite similar in 2020 and 2021. Thanks to direct drilling, we yielded and harvested more than before, despite the extreme weather conditions in some instances. And we have really reduced the amount of nitrogen fertilization. This year we used 140 kilos per hectare, and we also there is myth that plant protection means and substances are increasing in direct drill, but actually we used less fungicides, and the weed control is not so topical as well. If we are speaking about nitrogen, in our farm, when we started also including legumes in crop rotation, the amount of nitrogen fertilization reduced quite a lot, and namely these are 30 to 40%, and we have also managed to increase our harvest and our yield. Less pests, and benefit is that hard weed control is carried out quite better if compared to previous crop rotation, and wheat is only in oil rape, and in legumes we can use appropriate plant protection substances, agents, and also herbicides. We have a crop rotation of 4 crops. Sometimes farmers are using up to 7 crops in their crop rotation as well, so I'm not an exemption therefrom. Also, our dependency on nitrogen fertilization decreased, and also structure and composition of soil improved quite a lot, and also biological activity, brainworms increased in a number as well, and the soil is not compacting so much. The machinery is not drowning into the soil and is not going under the soil. Very good water infiltration capacity increase, and as Yanis has mentioned, we also witness improvement in soil's health. Also, biological activity increases more and more, and it seems that we can't already escape rainworms. If a farmer is really also an angler or fisherman himself, so you can use really quite a good source of rainworms for angling as well, and that is another benefit for soil health and also for other hobbies of farmers. As regards machinery, it crosses fields quite well, and also infiltration of soil through these capillaries and root channels made, as well as a rain worm canals made, water infiltrates better, and then it can return and raise up in drier periods. Of course, we have also threats and disadvantages and some risks. Of course, to use and to start no-drill technology, knowledge is required because it's very easy to mistake. And I'm happy that I have a group of like-minded people and I have a circle of advisors. I can call and show a picture and have some advice, but it's clear that, of course, if the no-till technology in a farm is expanded quite fast. Knowledge of experts is needed and advice is needed. Also, limited sowing time, which is more homogeneous, but we must be very patient in the when the factor of precipitation is more significant, so we must be very patient. For instance, if it's fog in early morning, we have to wait while the soil becomes dry enough. Soil dries slower, especially during springtime when all the neighbors are already sowing, so we must be patient and wait because no crop likes when it is put into wet wet and actually very humid. So therefore we are sitting at home while everybody else is working. No-till technology or direct drill needs general purpose weed control. And the question of glyphosate, if glyphosate will be prohibited, some alternative will occur and will be offered, or laser weeding machines or robots will occur as well. Of course, where is certain problem with one germ weeds, monocot weeds, but in practice, one species of these one cut weeds has appeared, but we are controlling it quite well. Micro terrain, this is compaction of one or several specific spots where the tractor is going across or in last field days, I was very pleasantly surprised where the tractor is going several times. The compaction is not so significant, and of course, direct drill fields are very suitable for snails. And before, actually, we used limicides, and we also protect oil rape fields and our crops. So, and unfortunately, fortunately and luckily enough, I do not see any other huge risks in our direct drill or no-till technology fields. But I could also sum up some phenomena, some factors we should pay attention to, which is movement of machinery on the field with less strong and lower pressure tires because existing trailers of sewing machines left a very deep trace, and we had to decide in favor of lessening pressure in tires of machinery. Also, hay management, we must pay attention how high we are harvesting, how the grinding of hay and what the quality of hay disintegration is, and a harvester operation. If it is needed to stop, we must really disseminate hay quite well before we are moving forward. As well, post effect, if technology is changed, we have to pay attention what herbicides we are using because certain herbicides have some post effect or post influence on the next crop in the crop rotation, but therefore sometimes agronomists should be asked and advised. And of course, crop rotation is a very significant factor because I do not consider no-till technology as a very sustainable and successful technology for a long term.
Starpkultūra pupas zirņi
And how we do achieve this and how we work. So we have crop rotation, winter wheat, rapeseed, winter wheat, bees and peas, and also crop intercrops. We are sowing those who are freezing after the winter, and we also use we have noticed that these intercrops retain also nutrition and so we are fixing them. So do we do not let them be blown away. And also when analyzing mineral nitrogen, we saw that 1 year I had a situation when there was stubble left and no intercrop. Then we saw that nitrogen was already 60 centimeters deep, but in this intercrop field it was less, and in depth it was not available at all. So that means that plants had taken up all this in themselves. And also intercrops are serving as feed for all microorganisms in the soil, and they help to improve the places which are in the soil which are more compacted and more dense, and then the soil is less compacted. And what I also noticed in very many places, it is actual that forest animals are there, and also they enjoy intercrops, and this means that they eat less of rapeseed, and this is actually good for everybody. And if we speak about intercrop stubble, it looks like this. In spring, we see that so here some plants are surviving, but it is also not bad for this. And this is the first year when we had our own drill and how we were drilling beans in that stubble. So in one pass, we have already sown legumes. And the result, after some weeks, we see already perfect picture. Actually, I didn't expect anything like this, but I was really happy. And almost every spring, I'm happy to see such a picture. And here we see already that we have 33 centimeters of inter-row distance, but we can't see soil at all. And when we do the same with wheat, here we have harvested rapeseed, and soil was moist enough, so we were So this rapeseed until August already has grown, so to be this green fertilizing, and we use herbicide, and at the beginning of September we can already perform drilling. So here we see quite a long straw or of rapeseed. Everything is going smoothly through, and it is a little bit moist, but we have this as sandy loam, and we can perform drilling very perfectly in one pass. So for the crop to grow, to germinate. So also here a friend helped me to show this. So here we see already a seed incorporated in soil, and here we have a mixture of soil and the remains of the previous crops. And so this is wheat in autumn, and we were happy about the result, but there are times when sometimes we have to use discs. We do not speak about plowing, but sometimes we have the doubt, and some neighbor has a better picture, and then we use discs. And when going home, so after wheat, and here it is the same. All drilling is done in the same day, and this was also autumn. So when you saw that the soil was quite moist, but here the soil was rather dry. But then precipitation started, and everything was fine. And we see that we saw that we have the best direction and correct direction. And in spring, on the left, we see that field after the winter, and on the right side, it's in June when we have ears already, and it's a very high yield potential. Here I have a picture from the same picture, which was drilled in first year with a very dry summer. And if somebody is telling us that it is a very bad weather, but if somebody other told me that it is possible, that I would not believe. But here is 6-7 tons. It is a rather good result, but here it was more than 8 tons per hectare just by replacing the way we think about this. We are really happy about this new approach, new technology. And on the same year, 2019, we tried to drill rapeseed with a disc drill, and it was the drill came. It was too wet. It came and it left, and we could not expect. And we called them again, and they came again, and they drilled it a little bit better result, but quite much of residues. But anyways, the result was quite good. And when soil is not moved, it is more lively, and the plants are less stressful, and they are developing better. And when you see this in maize, you can hardly believe this is the same field in May. So yes, you can try everything, and everything is perfect actually. What we are practicing during the last years, it is we are using precision drills in between the rows, and so then weeds can be harvested with longer straw. Less straw is on the field. Actually, rapeseed doesn't like the contact with straw, and we tried this for 2 years, and we take the previous year's AB line, and we use 10 centimeters to the left, and the saw directly in between these rows. So this is it from my side, and you will really not go bankrupt if you try this in one of your field. if you use a direct drill, no till, so it will be good. You shouldn't go and buy equipment. You can ask or outsource this from the neighbor or from dealers. Maybe you like and maybe you decide to buy it afterwards. But just for trying, you shouldn't buy such a drill. So three pictures. These are from my fields. I was going around and I noticed. So the first, I assume these are some. It could be foxes. Second is definitely these are fox system, just in the sand. And they are living there. Uh, so on the left it could be also a raccoon, and I know that there are problems sometimes with foxes, and also we see different birds, and I invite people to think about different animals in the nature. We need them, so for them to capture or these mice, for instance, and you have to have such trees where birds can sit and see where the mice are actually. Yeah, thank you very much. Thank you very much. And there are also some questions. So one is from practical point of view, about your fleet of equipment. Do you have enough machinery? Can you do this direct drilling? So maybe he thought about his farm, but maybe you could characterize how you have changed your machinery. We replaced a drill, but actually I know there are drills with which you can try to do this, but you also can use this min-till or shallow management cultivation, but you can ask from neighbors. Maybe that is not the cheapest way, or take from dealers, but this also covers the drilling costs. So there are no economic hindrances. No. A question which you also touched upon uh, about diseases. Hadn't these intensified? No, definitely no. Actually, last year it was the first year when I really felt sorry, and I thought that I could survive without fungicides actually. But actually, I had those stereotypes and I used fungicides, but it seems that I didn't need them. But actually, we have reduced the dose, and everything is fine with this. And then one more provocative question about have you thought about to switch to biological or organic farming in future? Actually, it could be so, maybe one day, but then you have to start from the other way around. You have to understand the way of how your consumers things have to be changed, and they have to demand such products, and then we could grow these, and then farmers would go for this process. Because organic farming, so that I would not like to return to, but if science develops and if everything develops, then why not? And one more question: what is that or was the largest hindrance, or when you wanted to try this no-till technology, what was the your hindrance? As I already mentioned, we understood yeah, that this big drought, those two dry years, maybe if they were not there and if everything was fine, we could not, we would not try this, but actually we have this clay soil, and it was nothing to lose in this situation. In that heavy field, which we also provided for the project, so that was very tough. And we could not lose anything. And what is your biggest surprise? You were not ready for what you were not ready starting this project. That feeling that you see how the plants feel when you use this in spring and when everything is emerging, and and growing, this feeling when you see that everything is growing through the residues and the field is really alive. So you can't even trust this your eyes. Yes, thank you, Ivars. And we will invite our next speaker, Ruta Abaya, from the Institute for Environmental Solutions, and she will tell us about controlled drainage and how we can use this for the adaptation to climate changes. Hello to our listeners, and I was happy and honored to join this project. I took it over from my colleagues, and our main task in the project was to make the controlled drainage and to show how it can be used in the farming and how it can be used. So the first is not everybody knows what controlled drainage is, and here I have a excerpt from melioration.lv, where we can see melioration systems which are in use in Latvia, and here is one picture how the such drainage system looks, and I have emphasized this control well and this difference when you have this controlled or covered drainage system. So the well can look differently, but the most thing is what is inside. So what is in that well? In the classical drainage, there will be a collector, input and output, and you can't see anything there. But in the control drainage in the well, you have the flap system, and this is a system with which you regulate the flow of water. And in this case, in the project, we were focusing on this outlet regulation, but how it is defined in the laws and regulations, then so you see a definition. It is double-sided moisture regulation structures in drain control wells or on drain collector outlets. But in the world, not only controlled drainage is perceived as a system in these control wells, but here we also see in the picture, so here you see that in other places in the world they also put these on collecting ditches. I haven't seen such in Latvia. It is not used so widely, but I would like to mention that such exists. And here is one also a picture from from the world. Also could be such a structure, and it is put on the drain collector, and it is made of stainless steel, and also inside the well you see that this flap, and there is the water flowing over at that moment. And I will start with how to understand and why this controlled drainage is needed and why it is worse actually. So here you see at the fields, this is recommended for fields with comparatively flat surface with a surface slope up to 1 or mostly or 2%, and it is worth making with a seasonal high water level. And in literature they say the water saturation is formed as, down to 46 centimeters from top layer of soil. If such a field is not equipped, so to say, with the drainage system, so this could be used for fields with sufficient water to regulate. One more criterion, the size of the field. Smaller fields, 4 to 8 hectares, so it is not rational or efficient to make such drainage because too small volume of water to be regulated with the system. And the last point here, so this comes from our experience in the project, and as we know that in Latvia, when it compared to Europe or USA, so our soil can be very different in one field and different structure, and it could be because of the movements of ice in these territories, and also this should be taken into account how uh, how uniform the structure of soil is. Therefore, there is this recommendation to use this such type of drainage with the uniform soil structure.
Here I have emphasized the preconditions for covered drainage with the changes per 30 to 60 centimeters. And here one water level regulation well should be established, or regulation or control well, and in a field per each 4 to 8 hectares, one water level regulation well should be established. It comes from global experience already, and the same preconditions should be taken into account when establishing fields where drainage systems had been established and whether those are compliant with the current provisions.
Priekšrocības kontrolētās
So
drenāžas
the main advantages of controlled drainage is the dependency of drought being diminished, and what also other best practice from and best experience from the world have been taken into consideration and transferred within our project. This method also prevents the nutrient leaching from soil, and farmers would need less nutrient replenishment needed in the future. And from an environmental perspective, it also reduces pollution of water with nitrogen and phosphorus. These connections and the reduce being flushed into the nature. This method is potentially also beneficial for reducing GHG emissions from soil. Of course, literary sources and bibliography is quite varying in that topic, but we checked and tested that within our project. What are the benefits of the controlled drainage, meaning the dependency on droughts and impact of droughts being diminished? My colleague Jānis Kažotnieks also has mentioned the trends or last experiences of Latvian territory in extreme weather conditions, and our average air temperature will increase per 3.5 to 5.5 degrees Celsius at an average. Vegetation season will be prolonged per 1 month, which would be a good news to farmers. But the situation is totally different with precipitation, because in terms of amount and extension, it will increase in winter time and less in springtime, as we have experienced that for the last 2 years. And summertime will be that period when long-lasting and more frequent drought periods will be experienced, which is bad news for farmers and for all the population of Latvia and other countries. And in the future, the periods and extreme periods of extreme drought, hotness, or precipitation could be experienced in the future. This is our national meteorology and Geographical Meteorology Center's database and data provided on precipitation, historical data in Latvia, and also future trends. We could pay more attention to that and take a look more frequently for better understanding and better knowledge of our weather conditions and trends and perspectives of those. And the points in terms and in the direction of increased and more extreme quantity of precipitation being experienced in the future, and that will evidence to the forecasts already being mentioning for several years and several decades. The next topic, we should understand how to act with that system, and it should be mentioned that in the term double-sided moisture regulation structures in drain control wells or on drain collector outlets will be mentioned in terminology and in legal provisions. So that will mean more, and the legislator will imply the regulation of outlets where it is irrigation and drainage system combined for depending on a specific crop and of the stage of development of a plant. It will be important to keep this level of water and wetness and humidity slightly below the root bulb level. And within our project, we did not include in our testing and in our validation the irrigation part, but we studied and tried to validate the necessary favorable level of water saturation necessary and optimal for plant development. And the seasonally, how these both approaches have similar techniques and methods. When nothing is growing in the field and there is no vegetation on the field, so the water level, so farmer is trying to keep that water level as high as possible to reduce in case if conditions in the field is too humid or for cultivation, for harvesting or for sowing by machinery. Shortly before that water level should be reduced to the necessary level and then replenished back, necessary during a vegetation period for the plants to grow optimally. And the third picture, I would like to repeat that depending on a specific root system of specific crop, the water level should be adjusted appropriately. From the University of Biotechnologies in Jelgava, the optimal level for Latvian conditions would be, and we must really pay attention from the top of the top surface point of the soil down to the root system. Of course, specific preconditions exist for controlled drainage regulation. First of all, that refers to the depth and intervals between the regulation valves from the top of the soil and terrain for homogeneous regulation of water level throughout a field where such system is established. And of course, we must pay into consideration whether the field is anticipated for a growing season or vegetation as for winter crops or for summer crops, because each crop has its specific root system depth and also stages of development where the regulation of water level should be followed as well. For convenient use of controlled drainage, it is advisable to establish those valve for mechanical or automatic regulation of water level. Such option should be included, and it is also advisable that centimeters and measurement devices of water level should be established for specific marks for specific and appropriate field should be recorded and could be followed while a specific controlled drainage system is being adapted for specific field. When we recommend also to establish for one control well as well observation of groundwater well, which show a real situation where the plants are growing, and of course it can be quite simplified according to the observations in the field on the soil surface. That will help and assist the farmer to gather and collect those statistical data and dynamical changes of those statistical data in the period of time. We had two testing places in Smiltene, which is a field of 54 hectares at a farm Roškalni, and the second one located in Mengele with a field of 43 hectares where the companies of the farm, Tilba and company Uppsala, are located. And we also cooperated with all the stakeholders involved in the project. As regards controlled drainage territory pilot project in Mengele, so controlled drainage fields constituted 21 hectares with reference fields of 22 hectares, where the surface slope in the fields constituted 0.5 to 0.8%. So we used that baseline or reference field to really test and validate our controlled drainage. So we have three sub-territories. It is important that all sub areas complied with the precondition. Soil differed. I will share later on as well, but majority of fields that was heavy sandy clay, and in a specific fields, amelioration had been carried out in 1978. 75 and 1983. Interval between the drainages constituted 10 to 20 meters, and crops used were winter wheat, summer wheat, and oat. I would like to mention as well that special attention should be paid to the fact for the fields and for the terrain be not totally plain and with some slope for results to be comparative. The second web pilot project fields and controlled drainage fields were located in Smiltene of 20 hectares and reference fields of 33 hectares, which was actually one area with controlled drainage field for testing and reference field next to it. The surface slope constituted 1%, which is the recommended one. That was clayish sand as a soil, and amelioration was carried out and established in early Soviet times in 1957, 1973, 1975, with the drains being located 18 to 25 meters apart. And we had winter wheat, summer wheat, and winter rye being used as crops. So the time frame for our controlled drainage design and installation or construction in Mengele and in Smiltene So we started in early December 2019 in Mengele, and approximately 1 year was needed. And in Smiltene we started a year later, and we needed 2 years for total establishment and launching of the controlled drainage. Here, some stages of the project were postponed or suspended in order so that we could gain our experience and really include it into the second project in second area. At the website of our institute, we have such one leaf information regarding the adaptation of amelioration system to the controlled drainage requirements and how that looks also during this currently already universally used BIM system of building information management system. And in these pilot areas, we had technical information gathered and provided as the previously amelioration systems were established in the field of our project. We required to clean and de-vegetate the ditches, amelioration ditches before and after works were carried out, and the existing drainage system and pipe lines were flushed and cleaned so that it would be fit for launching. An example from our construction design as this control well looks like, so the sketch or graph of that cross section from Mengele, but it was very similar also in Smiltene. So we had accumulation ditch, and this regulation or control well was located next to the ditch, and how it looks like in cross section. So inlet, outlet, and in the middle we have this valve system established or installed, and also the magnification of the same joint where from the well consists, but the principle is the same. As I've mentioned before, that these meters should be included as well in Mengele. We had reinforcement concrete well with and also of the wood elements were used, but we experienced that these were not so dense into compacting, and therefore the more efficient structure was used afterwards from different material, polymer materials, and at the very end we have a gate which could be opened for a drainage, for controlled drainage. And in Smiltene, a solution looks the same, but the well was already made and constructed of polymer materials. As I've mentioned also that it is advisable to have those water level meter not higher than the valve system, flap system, and it will never be higher than this flap system or a flap gate. Therefore, this is a practical note. As regards results of our testing, and what not to do for a project. And we have also concluded that controlled drainage is good enough for holding the humidity and maintaining humidity. Separately located area in Mengele. I also please remember that initially I mentioned that in literature sources elsewhere in the world for controlled drainage should not be less than 4 hectares, and we can see that in our tested area it was less than 4 hectares, and namely 3.4 hectares. It was encircled by these deep collection ditches, and as it was previously established a melioration system and established that we saw that we only could establish these 4 needed control wells, and in practically throughout the project, even after springtime, when the soil is most saturated with humidity and with water, we had nothing to regulate there. And I would like to supplement that it was a sandy clayish soil, and we initially observed that top soil had approximately 30 centimeters deep, where the peatland started, which is water passing through capacity and infiltrating capacity, and in at the bottoms of ditches, for instance, also melting snow was collecting on water from melted snow, but it was absorbed very fast. Also, the measurements of groundwater level indicated that we decided to close all the flap systems or flap gates to really observe that total maximum water level where the top of the service was located, with a grey line being depicted, and the green line depicting also the beginning of drainage regulation, starting from the 23rd of September 2022, where we could observe differences in groundwater. And regarding last year, which was comparatively extremely hot and dry, starting from early May to end of July, there was no precipitation, and that was the moment that we could really observe the maximum efficiency and effectiveness of controlled drainage. Unfortunately, we missed the data as automatic logger was faulty, and we didn't collect any data.
Kur kontrolētā drenāža kopumā ir?
Next result, which I would like to tell you, is in Mengele with 7.3 hectares, and according to literature and sources, there should be not more than 2 wells, but due to historical reasons and existing situation, we had to make 4 wells. In spring, water level was very high with overflow, and there was enough water to retain and regulate. But here the situation is very peculiar, with the fact that in the field where it is regulated, this field is 2-3 meters higher than the reference territory, which is chosen here. And there naturally there are, in this point, if you see it, so there's just a peat place where you cannot actually harvest and grow anything. And also here, by raising the water level, also this beside lower territory also becomes even more moisture and wet, and also the level of groundwater level shows that reference territory is with higher groundwater levels than in the controlled drainage territory. But here, what it is worth observing, how close these curves are, and this by how much you can raise the moisture level and groundwater level in this field. So here, August and September in 2022, the difference is bigger, and also it has been a longer period without precipitation than last year when it was this long draw. dry season, then it was even closer when there was no regulation at all, and especially when it is dry and hot conditions, and also evaporation of moisture is more active, then this difference is 20-30 centimeters. So with all this, also when you are on top of hill, you can use controlled drainage and to increase the water level. And this is the third subterritory in Mengele. And this is, I should say, the most successful in this project because they are both these parts. They can be compared by relief, and also the number of wells could be smaller by theory, but it's okay. And also, and here we should say that we noticed that naturally the soil is with higher content of sand, and also in wells the level of water was lower due to the peculiarities specificity of soil. Here we should see the red and blue line. So the blue is controlled drainage, and also data was not complete. So these are the data where we have received data all the time. And red line, it is the reference territory. And here we can see before regulation, and the difference in water levels is quite small, some 10 centimeters between the ground level water. But when regulation has started, especially in April till September, then we see the difference is bigger, and it is at least by 10-15 centimeters, which is not much, but we have to take into account what I mentioned before. In this field, the ground level, water level is low, and through all project time, we didn't reach that one season, which we had last year when soil would be oversaturated with water, and we had to open those flaps. Obviously, naturally, the soil is with good filtration peculiarities and abilities. And about Smiltene territory, here, what I already told, wells are by all installed by all recommendations by size. 2 wells for the drainage field, but as already said, reference territory is a little bit higher by 6 to 7 meters. This difference is, and so in the controlled drainage fields, it is 2-3 meters height difference in the field, and here we had to regulate. We had to regulate the water level in wells. So green line shows the time when we completely close the flaps, and the blue time shows when we had to lower the groundwater level immediately after snow melting period, when we saw too moist conditions and the moisture coming up to the surface. But we could not, of course, know that it will be such a dry season afterwards. And if we knew before, we could close the flaps sooner, and the loss of water curve would be not so steep. And the water would be there in soil more available for the plants. And here, when we see these curves, the groundwater levels, then it is higher in the controlled drainage field compared to the reference field. And here just pictures how it looks like, and this is the moment when we are coming to the field, and we understand that we have to open. They are in these natural pools, but here in this year, due to controlled drainage, they were even bigger than naturally, and we decided to lower the water level especially because there are winter plants, winter crops. And here we see colleague who is going into the well to regulate. And very short about greenhouse gases. We were measuring this, and we saw that we have to continue this measurement because the results are very different. We have pictures from two best territories where to regulate the water level, and in Mengele territory and also in Smiltene in 2023, due to some reasons. In general, the emission of CO2 were higher, but in controlled drainage there the proportion towards the reference was smaller, so the emissions were slightly smaller. So these volumes are small, but in general, again, in Mengele, attracting carbon has been better, and in Smiltene it is again different. When it is wet and colder, then the attraction or sequestration is better, but in some places it has been even emission, a place of emitting sea. But with the methane, they are too small values to actually to look at them. So this is due to mineral soils. And main results, so if there is water to regulate, then it is worth regulating when you have the regulating drainage system. If it is organized according to recommendations and features, then it is worth doing. If water is retained and also nutrients are not leaking. Last year there were no water sample to take, and it means that also these nutrients are not leaking, what I already mentioned. And regarding emissions, then these studies should be continued to compare these results. And the main recommendations and statements which I would like to tell, so draft will be more and more often. We will have to take this into account, and control drainage is one of the solutions, especially in flat fields to receive potentially more stable crops which do not suffer so much from the drought, from dry seasons which are expected due to climate changes. And what is also recommended in other places in the world, so also irrigation system is so that it is very safe. You can both control the input of water and moisture to the field and stable level. But this also will cost much more. And the last which I have mentioned here, so what is the Latvian situation should be taken into account. Fields which have been drained before, who should evaluate whether these drainage systems are suitable for this system. Not always they are working properly, and they are not to be used for these, and especially when it is winter crops, especially after melting snow to and also even if the soil is not freezing in winter, then there should be oversaturation with moisture, and you have to start regulating and reducing ground water level. But you also have to remember to close these flaps and not to have too small or too low level of ground water. So the flaps should be closed in the proper and the exact time. And regulation, of course, it is not so easy to do it immediately, properly, and you have to take into account that some seasons will pass until you will learn to regulate properly. Is it worse? Was it worse? Do you also calculate the economical profit or benefit of such system, installing such system or adapting the existing melioration system? Well, yes, we did not calculate so properly. Also, farms cannot provide us with such detailed figures. But after last year, when we started regulating in Smiltene, the farmer said that also due to the last dry season, he said that we were not successful in the beginning. We could not regulate precisely, and there were drawing rye, if I remember correctly, and it was pool standing, and development was later. That years, even though all these calamities and the yield was the best in that field, we were happy. Economically, this is what I mentioned. If you read sources, then we can judge just by results can be different, but for us it is the first project in Latvia, and starting from these 4 to 8 hectare fields, it is economically feasible to install such system. So you look into future with hope. Yes, really. And now we are going to give floor to our Czech speaker, Mikal Kepka from Czech Center for Science and Society, and he will tell us about utilization of modern IoT sensors in agriculture. The floor is yours.
Thank you. Hello, Latvian. My name is Michal Kepka. Thank you for introduction. I'm from Czech Center of Science and Society in Prague. We were partner in this project, and I would like to present our activities and technologies we are using in other projects as well, together with other colleagues. So I will start to share my screen. We can say that data are very crucial component of information systems. And these systems are not, let's say, just technical components, but these systems are used in many domains. So not only for information society. And we are trying to incorporate this pyramid of data flow, let's say. So we have some data. We are adding some knowledges or some other attributes to get some information from such amount of data. From such information, we are able to gain some knowledge based on other experience, based on other occasions. And then we are getting some wisdom. And based on the pyramid, in many fields, we are able to make some decision or support some decision to do some activities, to do some intervention in the field or intervention in this drainage systems, how to control, how to measure values. It's really important to have these qualified decisions because of the climate change, because of the very quick change of weather, and because of willingness to have some good production of the fields, good yield in such year in many changing conditions. So we need to effective manage. We need to effective manage all activities in such conditions and such, let's say, even legal frames. If we are speaking about sensors and the, let's say, global topics called Internet of Things or IoT, so we are not speaking just about some small sensors measuring temperature or measuring humidity, but especially in agriculture, the sensors are very important in many subdomains, in many disciplines. So we are not measuring only meteorological phenomena. Like you can see on the image on the right side, standalone weather station, monitoring air conditions as well as soil in the ground. We can monitor water and its attributes. We can monitor biomass, leaf wetness, leaf area. We can as well monitor livestock. not only position, we can monitor health attributes of livestock. As well, most of the manufacturers at this moment are providing tractors or any machinery with some additional sensors to monitor the conditions of machinery or to monitor what activities they are doing on the fields. So in case of IoT, we can speak about in situ measurements. So what is really provided on the same location, same connect with the object. Or we can speak about remote monitoring. So some optical measurements or some multispectral measurements of features of objects. So the most famous example is this kind of satellite images and vegetation indexes, for example. The challenge what is connected with IoT is not to collect data because it can be very easy. Just install measurements and collect data. But the problem starts to be with amount of data and how to process all this amount of data and how to process it effectively to gain all this information and especially these knowledges. So to get the value of the data. In case of LifeCraft project, we were participating in this controlled drainage monitoring. So we were monitoring water inside of this controlled drainage system, not only level of water, what is the altitude of the water level, as well as the temperature, but we were monitoring atmospheric conditions as well. So basic conditions and mainly precipitation for the locality. So there were installed sensors, these drainage wells, as well as meteor station for each of the pilot locality. On the right side, I suppose you have seen it today already many times. So it's one example of this location of this control well. But were used in these pilot localities. So we were using commercial sensor for temperature and water level measurements from company Meret, and this agronaut control data logger that is produced by Lespre company in Czech Republic. And we were measuring this level of water, so how deep is the sensor in this water amount, what is the water temperature, and based on this immersion of sensor in water, we were calculating absolute level of water in meters above sea level, so to be able to compare amount of water in each well. This type of data was collected with hourly frequency, so there was even then a lot of data, and it was visible changes during the day when there's movement with this drainage controlling mechanism. On the right side, you can see example of this data logger open with some service maintenance, and in the middle you can see this set of data logger with this water level sensor. Each pilot locality in Menděle, even Smiltene, was equipped with autonomous meteor station. So it was used this standalone Atmos 41 type from Meter Group, and it was measuring, let's say, basic conditions of atmosphere, so air temperature, relative humidity, air pressure or vapor pressure, conditions of wind, so speed, gusts, direction. The important one was precipitation measurement, then solar radiation or strikes as well. These measurements were provided in 10 minutes frequency, and again equipped with agronaut data logger to collect data and send to the central data storage. experience from these measurements can be that this autonomous meteor station needs at least some, let's say, maintenance for months, 2 months, because even then the field is covered with some biomass. The dust and the combination with precipitation is really, let's say, damaging the measurements of precipitation. So it's the funnel that is used for these measurements. It's really necessary to keep it clean, even we are in the middle of the fields. All the data collected by sensors are somewhere stored. So we were using open source solution SenseLog, that is one of the product of big international consortium where CCSS is involved as well. And this solution is able to receive data, store it in some database, some initial preprocessing already to provide, and publish by different set of services. So we are able to connect to different applications or different other solutions from third parties. This solution is providing simple and standardized interface. So we are not limited to any product. And this solution already has some, let's say, group of other components for some analysis of data, so some basic analytics component for some statistical evaluation, for some threshold monitoring. Then it has some monitoring. It's a monitoring component called watchdog, so monitoring conditions of the network if all sensors are measuring, if there is no problem with some data storage and so on. And we have some client for data visualization as standardized component. For this SenseLog Analytics, it was part of the development for craft project. So the main purpose is really to some statistical evaluation of data, some calculations of extremes, monitor some thresholds. So reaching some threshold, especially some amount of water in wells, or some freezing in the morning, or monitor some combinations of values. So typically some conditions for arriving of some diseases in the field. And these, let's say, monitoring or analytical results can be reported somewhere. So even on an email or just by SMS or some alerting mechanism to other components. So this is just for imagination how it looks like. So it's stream of data where we are monitoring values and combinations of values in different periods of time. What we were using for visualization for, let's say, final users or farmers, we decided to use again open source component called PIA20. So it's a result of one previous project in large consortium where two Latvian companies were already involved. It's one web map application that is able to integrate data from different sources. So it's provide some visualization of measurements together with spatial data, some thematic map layers, together with meteograms or set of analysis provided from external services. So the map is able to visualize not only location of sensors, so that's the one user would like to see, but in combination with other map layers. So these drainage systems or field blocks from LPIS database, water lakes or rivers, or types of soils together. The application is providing some set of analysis as well, so it can be defined analysis from the user, or it can integrate these external services. So weather forecast or agro-analysis provided by external service. In this case, it was by MeteoBlue from a Swiss company for weather forecast. The application is open, so you can visit the application on this URL mendele.ccss.cz, and it's simple web application in Latvian and English language. So this is example how it looks like when you are visualizing field blocks together with drainage systems, water and rivers, and how it looks like in a map. The second option, what you can visualize in this window, is to add some chart with measurements. So in this case, I'm visualizing 4 measurements from this wells. So it's water level in absolute value, so with elevation of the water level in period of 2 months, and you can see all these 4 wells on branches of one system of this drainage pipes. So how it is stable during the summer 2023. As external service, it's possible to connect this analysis from MeteoBlue. So this is example of meteograph for 7-day weather forecast, even containing some basic analysis. This spray window, it's recommendation based on weather conditions, if it is good, possible, or very good options for spraying on this area. As I was mentioning, it's possible to add other thematic layers. This is example from NDVI index, so it's calculated from satellite images, from Sentinel-2 images. It's for different locality, but it provides the same overview how the biomass or how the conditions of the field is changing during the time. So it's possible to calculate these scenes for any day it's available. So visualize it in combination with other components. For Smiltene exists similar application, so it's again open and available. This is again the same example, but with different base map under the sensors. So it's containing orthophoto image from your national provider, and again with some combination of sensors in this locality. So this is visualization of precipitation during summer 2023 in millimeters per hour. Okay, that's all from my side at this moment. So if you have some questions, I will be happy to answer them.
Jā, liels paldies, Mihal. Mums ir ienākušies.
Thank you very much, Michal. We have several questions. How much such a system would cost to be established?
It mainly depends on, let's say, amount of sensors. So we can speak about meteo stations about 2,000 euros. For this water well is, say, 200 euros per one installation, with some small amount of service or maintenance fee per year for data storage and for development of applications. So it really depends on the size of the area.
Jā, paldies. Un noslēdzošais jautājums, vai jūs šādu...
Thank you. And final question, do you offer such services also to Latvian farmers?
Yes, we were already cooperating with Baltic Open Solution Center, which is seated in Riga, in the main center, or you can contact partners from Craft Project for let's say direct contact to us, even LDF or with this institute, and we are very welcome for any customers who really would like to be involved in this testing or using of these systems for sensors.
Liels paldies, Mihal!
Thank you very much, Děkuji. And we have reached our final presentation for our conference for Mr. Jānis Reihmanis from Latvian Environmental or Nature Fund, who will be talking about use of biochar in growing vegetables under the organic farming conditions in Latvia. And I would like to share about biochar. We were testing within the project for industrial farmers in Latvia. That term would not be so well known, but biochar has quite a long history in application and in the use. And to a great extent, it is based on historical data, which have been discovered for Amazon civilizations with historical excavations, when very black, very uncharacteristic soils were discovered, and after analysis, it turned out that biochar had been used several thousand years ago, and soil profile has changed, but they can be discovered as very dark, almost black soils can be discovered. And the use Spanish terra preta term is used, black soil. And in those rainforests, several thousand years later, we can find those terra preta based on historical data, historical experience, and also striving for climate change mitigation in agriculture in last decades. That's a topic that is very well studied and researched. There is a lot and series of articles, scientific articles, and research and studies and theses done in agriculture, ecosystems, and environment. What our benefits would be when biochar is added and used to agricultural soil. And similarly, we can also experience that the question is also studied practically. There are lab tests and also field tests up to the extent that biochar can be almost bought as a commercial product already on the market. It is launched and has introduced to the market already. Results are quite different. There is a set of factors affecting the outcome, and the safest positive effect can be witnessed by lab tests, which is quite clear and quite expected that it is possible to control all other factors in the lab or exclude some impacts, some side effects, and also contribution of carbon itself to those research. But research R&D is very active also in the community of scientists, researchers, and practitioners already. But it is significant to understand that in Latvia, very often and very long-standing, every rose grower knows that ash should be used in garden, etc., or for some other crops where ash is used. In this case, we are talking about totally different substance, because ash is potassium fertilizer, dust-like or flavor-like small fine particles, as physical form is very fine and powder type, and under a microscope we see that this is very fine molecules, but biochar remains its porosity, and it is very peculiar area or space unit, and various larger and smaller pores are remaining, where by means of which we can attract various microorganisms, and it serves as a medium for various soil bacteria, mononuclears. And if we are considering those physical characteristics and properties alone, we can expect what the beneficial impact of biochar could be, and what would happen if we really integrate biochar in our soil. And this is a source absorption of nutrients and a gradual release, and also a living environment for habitat for living organisms. In practical terms, biochar is usually used not as biochar into the soil, but is really important to process, saturate with nutrient medium, for instance, mineral fertilizers, compost, or sludge, or some microorganism growing medium, inoculation, so it should be inoculated. First, saturates that biochar, and totally, quite opposite, totally dry biochar has hygrophobic properties, and it means that if you put dry biochar into the soil, it needs some time for this water and humidity absorption capacity would develop, whereas it is able to release all those other positive effects later on. That would be theoretical part of what biochar actually means, but what we actually did during the project.
Trīs saimniecības.
We had 3 farms in our project. They were organic farms, which are growing vegetables, and the idea was that those who provide more kilos per hectare, and also money could be larger from one unit of territory. So when using small sample areas, we could evaluate these effects. And so when these yields would be bigger, then also the changes would be bigger. And what we did, starting from 2019, vegetation season, we had test samples, 0.4 hectares distributed in 4 parts. One was without biochar, one with 250 kilos per that 0.1, then with 1 ton per 0.1, and 2 tons per 0.1 hectare. And here we had different methods of inoculation, but we did it once at the beginning of the project. Afterwards, nothing was done with the char, and we tried to achieve or to see how it works in the field circumstances for a farmer when we offer such a solution, what it gives to the farmer, what is the income, what is the benefits, and what maybe are losses. So we didn't try to do any impact on the planning. Farmers did everything what they do on daily basis. The only precondition was the crops had to grow in all these 4 fields should be the same. So for us to be able to compare, so the crop should be the same in all 4 fields. So to compare, and the first farm in which we worked was in a Gulbene region, and should say from the point of view of farming, it was rather not typical. 3 years they were growing, soybeans, and yes, actually in Latvia it also is possible to grow and to have a yield. It is a little bit exotic crop. Here we used the biochar in 2018 at the end of that year, together with a green fertilizer with lucerne, and so we have one such farm with such type of inoculation. And what we got, so here we see results. We were measuring yield from all 4 fields. First year we also tried not only to measure tons of yield, but we also were measuring plant height. And what we saw in this farm was a little bit surprising, since what you see here on the right side, on the left side for you. So what you see where you have this linear curves of equitation, these are statistically essential correlations. And in this case, when you have soya beans in all 3 years, we saw that the yield is decreasing. The bigger is the volume of char incorporated in the soil. But when it is potatoes, then there is no difference. So here we see just the opposite result to the one which we could expect theoretically. Another one in Bauska region, one farm. Here also we were measuring, so here farmers were growing what they wanted. Biochar was incorporated through inoculation with the microorganisms, with substrate, our own biomix. So we have preparation biomix, which is on the market here, and what we saw here again is so the part of the plant above the soil, there is no influence. Also, no influence to yield of potatoes or carrots. But when they were growing pumpkins and when they were growing onions, yes, we saw there is a positive effect. So statistically, essential positive effect. The yield was larger in the fields where we had incorporated more of charcoal. So we were happy because this is what we expected. Again, not in all years, but 2 years out of 5 were making us happy with positive result. Another one in Čakava region. Here we used biochar together with manure. At the beginning of 2019, and here this practical solution was different. The field where we used biochar, it was quite poor, and the farmer wanted to improve the quality of soil in his field and also the crop rotation. But he wanted to use this green biomass and to improve the quality of soil. And also they gave us the worst field. So if we achieve something positive, then it is really positive for the whole farm. Otherwise, this was quite poor soil and field. What we see here, we see that fluctuations are different in all possible directions, but no statistical deviation, statistically significant deviation. Here, I tried to to cut that green mass and weigh and measure, and so maybe the mass is this mass is influenced. Also here we didn't see any statistically significant correlations. And in the middle, on the top line, you see so vegetables, different vegetables were grown perpendicularly to in this field. It was different root vegetables, but in none of these we saw any essential effect of this. So 3 farms, very different results, and we cannot say anything statistically significant, and no uniform direction, and no correlation, but results are really very, very different. But if we look at what we get from this, so this is a benefit for the company, for the farm. But from a climate point of view, because the result of the project was to improve the smart agriculture or improves smart management in the farm. From the monitoring we see that the total volume of carbon, if we compare the beginning of the project and end of the project, then the total volume, the sequestration has increased significantly. At the beginning, so if we compare the difference at the beginning and the end of the project, then we see that in those fields with the largest volume of biochar incorporated, the total volume of carbon has improved and increased. So we have attracted almost 2 tons of CO2 during these 5 years of the project. If we measure this total volume of the carbon. Another, how we can perceive this from the climate point of view. So the very biochar through the process of pyrolysis from organic mass. So it is char from obtained, and the largest part of it actually consists of carbon. There are different compounds which are in smaller concentration, but the largest part of this is really carbon, which is sequestrated, and possibly, as we see here from these terra preta samples, which will retain in the soil, not for eternity, but maybe for 1,000 years. These are very stable compounds which stay in the soil for a long time and are not leaching. It's like a deposition in the soil. If we incorporate it here, then it is staying there. And in this case, if we look at all our farms together, what we have managed, then it is 8.5 tons of carbon for all 3 farms together. So if we look at from the climate point of view, then this practice is really with positive effect. Although from the farming point of view, there is fluctuations, and so we cannot say what is really there. So what could we understand from this? Of course, field situation is different from the laboratory, and it should be taken into account, and also further studies should be made if we would like to use this method in a real farm. So there are very different local factors. In laboratory, you can exclude everything or control these factors, and in real field situation, even in 0.1 hectare fields, you cannot control everything. There are variations. There are more weeds or less weeds, more moisture or less moisture. Granulometric content even differs in this one. You can see it by eye. And also these factors really influence the yield, and possibly they influence the yield more than this charcoal. But this should be uh, examined and studied. There are cases when it works. In our case, it worked in part of the farms. And what we see and what we conclude from practical point of view right now, before we have understood more and before the world has understood it more, researchers and practitioners do this. Right now, we cannot recommend this such practices to large agricultural holdings as economically justified. It is too high costs and too unclear results. But for smaller scale farms where they maybe can produce biochar themselves, which is available, and they can produce on their own. We can continue experiments, and they could be economically justified. And especially, maybe the question is the volume of this, what is incorporated. And we see that there's a soil horizon, but for us it's 2 tons for 0.1 hectare. Uh, so you do not see a black horizon or black soil. So you can, when you go in the field, you can find those char, but you cannot perceive this with an eye. Possibly we can speak about some volume which should be incorporated, but this is most probably to be done in small volumes. And of course, what I already showed in the chart, the overall carbon, then it is this positive effect. So carbon is deposited in the soil, and char contains carbon, and this sequestration is very good. It is taking this out of the atmosphere, and you can look at this from this climate point of view, but we do not see economic grounds for this, and it cannot work in market economies.
Tas arī no manas puses viss. Tāda bija mūsu.
And this was our experience during the project. Thanks for your attention. Thank you, Jānis. Yeah, we have some questions about the economic reasoning and the benefits. So that is too early to speak. In some places we see this, in some places we cannot see this. But could you tell a little bit more about costs? What are the costs? Or if you would like to buy charcoal and incorporate this into soil? I was not ready for such a question. I do not have prices per ton, but no, I cannot be precise. But if you buy this as commercial product, then this is not actually feasible right now. Since incorporation maybe is not so expensive, in our small fields we did it manually by distributing it, but also during project we tried it to do mechanically. It works quite well with a lime distributing device. You can, if it's inoculated moist, then you understand the costs of such work. But the very biochar is expensive. We had it, it was produced from wood. It is like, it was a sub-project of when producing char for grills. But for barbecues. And it also coincided with the beginning of the war in Ukraine, and it increased the price of wood and goods that we managed to buy it before that. and actually the price increased so much that it was not worth speaking about it afterwards. If we can produce char from some byproducts which shouldn't be bought in the market, then possibly it is feasible, and then it is economically based decision. Maybe you have some recommendations. Where could you get such a volume of char if you do not want yourself to do this in your farm? Well, one of the ready solutions is a companies who are producing char for barbecues, and so when they have these residues and waste which are not good for their product, it is like their production waste. The smaller the fraction, the better. But then you have to understand at what temperature they have produced this, because one of the things which have to take into account is that the biochar, this is it is very variable product. It depends from what it is made, which temperature it is made, what have been the composition of the raw material. Also, soils are very different, and also in different soils, their features of charcoal are different. If we know about terra preta soils, these are actually they are with big biomass, but actually this soil is very weak, and most probably they had to use this to have some growing soil. It contains the soil, nutrients in the soil, and that they are not leaking. And all this, so biochar is so different, and also impact is so different. But I would like to say like this. Yes, one thing where to get it is these production sites of those wood jars. So we inoculate it to be able to incorporate this into the fields. And another aspect of what could be and what is, I'm also that sure about this, that it is worth working into that direction. Also, see, that could be a sector for industry. During the project, I had opportunity to visit a conference of biochar producers, and this is very topical issue. Factories are being built to produce such biochar. Yes, there are some preconditions, what conditions should be, what raw materials, and it is important that the raw materials are not to be bought, but this is really a business opportunity to produce biochar. Of course, we do not know what will be the market. It is important to reserve possibility to change the temperature, to change the raw material, but it could be also a business here. We do not have this in Latvia right now, but globally it is already in the process. And then this product could come to the market. Yes. Thank you very much. Yes, we see potential, and we will see how this will develop in future. Thanks to Jānis, thanks to others. Thanks for listening, and we do hope that you got something, and thanks also to you. And I do hope that you have practical mm, ideas to be used in your farm, both about methods which you heard today, and also later you will be able to read in the book. Which will be Latvian and in English, so climate-friendly agricultural methods. You can look for it in the Craft Life homepage, and also thanks to the Latvian Rural Advisory and Training Center for this conference, seminar, and broadcasting to your homes. Thank you.